Hello dear students, welcome back for your mathematics classes. So in the previous video we have started the unit 4, which is higher order derivatives, and there we have seen higher order derivative of e raised to ax plus b as well as the function x raised to n. Now we have proved, that is, if y is equal to e raised to ax plus b, its higher derivative or the nth derivative, what we have taken, yn is equal to a raised to n e raised to ax plus b, and similarly whenever y is equal to x raised to n, we have proved yn is equal to n factorial. Now see, in the exam they have asked you, that is, they may ask y is equal to x raised to n, then prove that yn is equal to n factorial, or else they can ask you to prove yn plus 1 is equal to 0. Yes, and how you are getting this, that is, up to this yn is equal to n factorial we have proved, up to that you have to take the same steps. Next, yn plus 1 is nothing but its derivative. Then what is this nth derivative? Then next derivative will be n plus 1. Therefore, that will be yn plus 1, and as this n factorial is a constant, as this n factorial is constant, so its derivative what we will get? 0. So in the exam, for the function x raised to n, they may ask you to prove yn is equal to n factorial or yn plus 1 is equal to 0. Yes, this you must know this. Yes, okay. Next we will take third example, example 3, that is, if y is equal to cos ax plus b, if y is equal to cos ax plus b, then prove that yn is equal to a raised to n cos ax plus b plus n pi by 2. Yes, here y is equal to cos ax plus b, this is given. Then what we have to prove? Its nth derivative is a raised to n cos ax plus b plus n pi by 2. Yes, this we will take. And in solution, I have already told you, our first step is to write given function, that is, given y is equal to cos ax plus b, I will take it as it is. Next we have to get the yn. For that we must get y1, y2, y3, yes, first 3 derivatives I will find. Then by generalizing them, I will write it generally nth derivative. Yes, let us take now first y1. So what is y1? Yes, cos x differentiation, we know that here cos x differentiation is minus sin x, and in place of x we have here ax plus b. So after this minus sin ax plus b, we have to differentiate this again ax plus b. Is that I will write here, cos differentiation is minus sin ax plus b, and again differentiation of this angle we have to take, that is ax plus b. Now again what is ax plus b differentiation? That is a I will write. And one more thing I will tell you, that minus sin theta is equal to cos pi by 2 plus theta. Yes, this formula we will use. Yes, minus sin theta is equal to cos pi by 2 plus theta. That is what? Whatever the angle is there, sin is, then minus sin theta we will take it as cos, and theta as it is, for that we will add the pi by 2. So here minus sin ax plus b is there, therefore I will take it as y1. Now I will write a initially, that is a into, and this minus sin is I can write as cos pi by 2 plus cos pi by 2 plus ax plus b. Yes, what we got? y1 is equal to a into cos pi by 2 plus ax plus b. Yes, I will tell you first how we got that minus sin theta is equal to cos pi by 2 plus theta. Yes, we know, that is, considering the 4 quadrants, here it is angle 0, pi by 2, pi, and 3 pi by 2. Now what we have? here. I will take cos pi by 2 plus theta is minus sin theta. Therefore, cos pi by 2 means here. Yes, pi by 2 is here and here it is change. Then cos changes to sine. Yes, cos changes to sine and pi by 2 plus theta. Plus theta means in the second quadrant. Cos pi by 2 is here, that is changed, here it is changed. So cos changes to sine. Then pi by 2 plus theta means pi by 2 is here. Plus means in the second quadrant. And in the second quadrant, this cos is negative. Therefore, we got cos pi by 2 plus theta is equal to minus sin theta. Yes, that's why I have taken minus sin ax plus b is there, no? There I can write cos pi by 2 plus ax plus b. Now, this is our y1. Let us take y2. Now, y2 I will take. Yes, again here a is constant. A is constant. We must take cos pi by 2 a plus cos pi by 2 plus ax plus b differentiation we have to get. Yes, that I will write it as y2. Now y2 is equal to a as it is. Again cos ax plus b plus pi by 2 differentiation. Cos differentiation I can write here sin ax plus b plus pi by 2 and this is of negative sign. And again by the chain rule what we have to get? Differentiation of this term, that is angle ax plus b plus pi by 2 differentiation. In bartadari ax then bartada, that is a plus a is their constant, x differentiation is 1, then b differentiation is 0 plus again pi by 2 is also 0. Why? Because this b and pi by 2 are constants. Now therefore y2 is equal to what we got? Is again here one more thing I have left, that is this different, that is here again this y2 I can write now. Here it is a into again a, that will I will take a square and again minus sign is there, that I will convert to cos. Yes, how we have to convert this? That is cos ax plus b plus pi by 2 again plus one more pi by 2. See, minus sin theta is cos theta plus pi by 2 is there. What is our theta? Ax plus b plus pi by 2 is there. Therefore, I will write here cos ax plus b plus pi by 2. Now, this is over and again that plus pi by 2 we have to add here. Therefore, I will write y2 as a square cos 2 pi by 2 I will take 2 pi by 2 plus ax plus b. Now this is our y2. Similarly, if I get y3, a square as it is, cos differentiation we have to get, again that is minus sin 2 pi by 2 plus ax plus b and into again this angle differentiation we have to take, this 2 pi by 2 and b, its differentiation is 0 and ax differentiation is a only, that I will write here 0 plus a into again that x differentiation is 1 and again 0. So now here it is a square and this is a, therefore y3 is equal to a cube. Again minus sin theta is cos theta plus pi by 2, that we will apply. Now sin is there, this minus sin is cos, theta is this whole thing, that I will write as it is 2 pi by 2 plus ax plus b plus pi by 2. Yes, this theta as it is and plus pi by 2. Therefore, y3 what it becomes? A cube cos 2 pi by 2 plus 1 pi by 2, that I will write 3 pi by 2 plus again this ax plus b as it is. See, for the function cos ax plus b, we have got first three derivatives, that is y1 is a cos pi by 2 plus ax plus b, y2 is a square cos 2 pi by 2 plus ax plus b, similarly y3 will be a cube cos 3 pi by 2 plus ax plus b. So comparing all these three I will write. So in general yn is equal to, see, for the y1 a power is 1, for y2 a power is 2, and again for the y3 a power is 3. Therefore in general I will take for yn a power will be n, that is what, a raised to n. Now this constant term is over. Again in y1, y2 and y3 cos itself is there, therefore cos I will write. Now compare the angle, that is for the y1 1 pi by 2 is there, for y2 2 pi by 2 are there, and for the y3 3 pi by 2 are there. Therefore for the nth term what we will get, n times of pi by 2 and plus this angle ax plus b as it is. Yes, this is what in general yn, that is what, a raised to n cos n pi by 2 plus ax plus b. That is what our answer here, that is yn is equal to this term. Yes, here I have taken ax plus b plus n pi by 2, or you can write there also, that is a raised to n cos ax plus b, then n pi by 2 you can write. So here remember, whenever y is equal to cos ax plus b it is asked, what we have to get first, that is y1. Cos differentiation is minus sin ax plus b, and ax plus b angle differentiation we have to take, that is a into 1 plus 0, that I have written a itself. Then y1 is equal to this a as it is, and minus sin theta we can write as cos pi by 2 plus theta. Therefore in place of theta ax plus b we have to take, therefore it becomes cos pi by 2 plus angle is ax plus b, that I have written. So this is y1. Coming to y2, here a is there, then y1 differentiation we have to do. Again cos differentiation is minus sin, that is angle is ax plus b plus pi by 2. If you going to differentiate again angle, again here remaining is a into 1, b differentiation is 0, again pi by 2 differentiation is 0. Therefore we left with a into this a I have written a square, and again minus sign converted to cos this function, that is this angle as it is, plus pi by 2. And in this step pi by 2 plus pi by 2 is there, that is pi we can write, just to generalize it I have taken it as 2 pi by 2. So we got y2. Similar way we have to get y3. Then comparing all the three successive derivatives, I can write here yn, that is a raised to n cos n pi by 2 plus ax plus b. So this is how we are getting nth derivative of the function cos ax plus b. So next example is getting higher order derivative of sin ax plus b. So till now we have discussed about cos ax plus b. Then next example I will take fourth one, that is if y is equal to sin ax plus b, then prove that yn is equal to a raised to n sin ax plus b plus n pi by 2. Yes, this example is also similar to the previous one, that is cos ax plus b. Yes, you try this, and here I will give you hint as, that is sin pi by 2 plus theta is nothing but cos theta. That is, again in the derivative wherever you will get cos theta, that you convert to sin pi by 2 plus theta and continue in this way, that is whatever we have taken for the previous example, and you will arrive at the solution yn is equal to a raised to n sin ax plus b plus n pi by 2. So this is third example. I will move to next example, that is fifth one. If, that is the function is ax plus b raised to n. Yes, fifth one. If y is equal to ax plus b raised to m. Then prove that yn is equal to, yes, whatever it is yn is there, that we will prove. Yes, here I don't take, yes, let us find that, that is, then find yn. Okay, just don't write this initially, let us get the yn first. Okay, so in the solution, again first step is to write given thing, that is given is equal to, given y is equal to ax plus b raised to m. This is our given function now. Again what we have to get? First derivative. So that implies differentiate this y with respect to x. Here it is in the form of x raised to n. Yes, if y is equal to x raised to n, dy by dx what we are getting? N into x raised to n minus 1. Yes, that formula we are applying here. Now our function is ax plus b raised to m. So its first derivative we will get it as ax plus b, sorry, m into ax plus b raised to m minus 1 into, now this for the power it is over. Now whatever this term is there, that differentiate we have to do, that is ax plus b differentiation is again a into 1 plus 0, that is a is constant as it is, x differentiation is 1 plus b is constant, its differentiation is 0. So what we got now? Here I can take a bracket. So y1 is, I can take this a into m into ax plus b raised to m minus 1. So now we got y1. Next we will move to y2, that is second derivative. As this a is constant and this m is also constant, I will write this a into m as it is and let us differentiate ax plus b raised to m minus 1. Again applying this formula, yes, in the place of n, here we have m minus 1. Therefore, what we get? M minus 1 into this function ax plus b raised to m minus 2 we will get, yes. Whatever power is there less than 1, that we have to write. M minus 1 minus 1 will be m minus 2. So y2 is, now again it is not completed yet. Here again we have to differentiate ax plus b, that is what? Again, yes, I will write directly it as a. This complete now differentiation, that is what? First a into m is constant, we have kept as it is, then ax plus b raised to m minus 1, its differentiation is m minus 1 into ax plus b raised to m minus 2 into, again ax plus b differentiation, that is a. Now a into a is there, a square, I will write m into again m minus 1, then the function, that is ax plus b raised to m minus 2. Now let us take y3. Here again a square into m minus 1, this is constant, keep it as it is, then this function differentiation. Now power is m minus 2, x raised to n is n into x raised to n minus 1, therefore in place of n we have got here m minus 2, that is m minus 2 ax plus b raised to m minus 2 minus 1, that is m minus 3 into, again this is over for the power. Next this ax plus b differentiation we have to get, that is into a again. So here a square into a we got, that I can take it as a cube, and into m into m minus 1 into m minus 2, m into m minus 1 into m minus 2, and ax plus b, remaining is ax plus b raised to m minus 3. So compare all the three derivatives, that is y1, y2, y3. Then we can generalize it. Yes. So, in y1 we can see here, in y1 a is there, in y2 a square is there, in y3 a cube is there. Therefore, in general I can write in yn power of a will be n, that is a raised to n. Next term is, see, in y1 it is m, in y2 it is m into m minus 1. Yes, as you have taken in the x raised to n, in the similar way here m into m minus 2 minus 1, that is 1. That is, this term continues up to this minus 1th term. Again similarly here 3 is there. So, 3 minus 1 is 2. Therefore, this term continues up to m minus 2. Whatever here this order is there, less than that one term, as up to that we are getting here. So, in generally we are taking nth derivative. So, now this m into m minus 1 into m minus 2, this term continues up to what? M minus, yes, 1 less than this term, that is n is there, 1 less than that means n minus 1. Yes, now this this term is over, and again now for the ax plus b, for ax plus b here 3 is there, ax plus b raised to m minus that 3 itself, and for the second order it is m minus 2, and for first it is m minus 1. Therefore, for the nth derivative it will be ax plus b raised to m minus n. Yes, it is m minus n. This is how we are getting by comparing y1, y2 and y3. Yes, therefore, for the function y is equal to ax plus b raised to m, yn will be a raised to n. Yes, this term continues up to m minus n minus 1, and power will be, for the ax plus b, power is m minus n. Yes, I will take one more step here, that is yn is equal to a raised to n into m minus 1, m minus 2, so on up to this is m minus n, minus into minus is plus 1, ax plus b raised to m minus n. See, whatever this generalized is there, yes, it is easy to get first 3 successive derivatives. You can do by using formulas whichever known for you. But by in general whatever you are writing, this is important. How we are comparing is that we have to check. Here for the y1 power is 1, for y2 power is 2, for y3 power is 3. Therefore, ಇಲ್ಲಿ yn ಒಳಗೆ ಏನು ಬರ್ತದೆ ರೀ, a power is n. Similarly, this m term, m minus, yes, this is only in y1 it is m, in y2 m into m minus 1, minus 1 term, this term how we are getting 2 minus 1, yes, m minus 2 minus 1, that is nothing but minus 1 only. Next here y3 m into m minus 1 into m minus 2, ಅಂದರೆ ಇಲ್ಲಿ 3 ಇದ್ದಾಗ up to 2 we are getting this term. Therefore, in general nth term we are writing, therefore less than 1 this term we have to get, that is m minus n minus 1. Yes, and this m minus n you are getting easily, that is what by seeing itself. Therefore, and this in the next step just you have to take m minus n and again minus into minus plus it is there. Yes, this you have to apply and ax plus b raised to m minus n. This is what we are getting for the function y is equal to ax plus b raised to m, finding yn, that is this term. Yes, this is answer. Just comparing and writing this generalized term, this is important. Okay, again some standard functions I will take in the next video. Okay, thank you.